Hello and welcome back to the AVLI AP Computer Science video series. Probably should have posted this last week, however, I was pretty sick, as people who attended the class might remember. And so I'm finally better, although I still have a little cold, not the infection that went with it. But, anyways, I wanted to cover an approach to looking at an FRQ question, and this is what we did in class. So you'll notice attached to the email are the questions and the scoring guide for what I'm about to describe. So if you want to look that over first, it's up to you. I chose the 2010 free response question number one, and I wanted to say what we're going to look at. Okay, so I have it open and it just says, some notes which are there on every single exam. Assume the parameters in the method are not null. Use the quick reference. You may use one of the accessible methods listed in the class defined in the question, etc. Okay, so it gives you a little bit of background, but I'm going to quickly go over this question, ignoring the text for a second. I'm going to look at and say it's a public class cookie order, and there's a constructor, a get variety, and a get num boxes. So I'm going to assume that a cookie order has a variety and a number of boxes. So really, when you place an order, it will have the variety. In the case of Girl Scout cookies, it might be the shortbread or something else, the mints, and the number of boxes like 10, 20, etc. And they have accessors get variety and get num boxes. Real quick, I'm just going to summarize over that and scroll on. And here we have a master order, which is, I suppose, a listing or a master collection of all cookie orders. And in fact, that's what it looks like. It has an array list of orders, and the type in the array list is cookie order. So you have a constructor that sets up the array list called orders. Please don't lose track of what the instance variable is for master order. But really, if I wanted to quickly summarize, one is implemented in part A and two is implemented in part B. So you have an add an order to the orders, you have a get total boxes, and you have a remove variety. So if given a variety like chocolate chip as expressed in a string, it will remove all the chocolate chip cookie orders from the orders list. Okay, so now I'm pretty clear about what we need to do, and I just summarize it. And maybe at that point, I'll go back and read the entire narrative. And here is a cookie order class, they describe it. And here is a master order, and it maintains a list of cookies to be purchased, and then we get to the part. Okay, and this is kind of important too. You want to read the get total boxes computes and returns the sum of the number of boxes of all cookie orders. If there are no cookie orders, the method returns 0. And you might want to look at the pre and post conditions here. They're important, they provide information. And what I would recommend here is to rewrite the method header, because everything is in the method header. What comes in and what goes out. So we can see an int is going to be returned, which is the sum of the number of boxes. So I'm going to go over here and show you what it looks like. Okay, so I have master order, and I just kind of write this up that says orders equal new array list. All right, so I don't want to lose track that what I'm going to be operating on is orders. And so it's supposed to return 0, and in this case, int total equals 0. I can't urge you enough to, when you declare variables, set them to 0 or a logical value at the start. In this case, I think we can simply go through using a for each, all right, and then say each element in the orders list will be stored in X for each step in the iteration. It can call the get num boxes and add to a variable total, okay, and then return total. So I think this is pretty clear, okay, using a for each loop. However, I also wrote it so that you could write it as a traditional for loop. In I equals 0, I is less than orders.size. Remember, it's size, not length for an array list, I plus plus. And then orders.getI.getNum boxes. So it's a little bit longer and more convoluted to use the traditional for loop over the for each, but it certainly can be done using the get method of the array list class. So let's switch around and see what this is worth. Okay, so I'm going to go over here to the scoring guide and say considers all cookie orders in this dot orders. And basically that is, did you write a loop? If you access any element of this dot orders, you get a half point. If you access all elements with no out of bounds potential, staying less than orders.size, then you get the other half, 1 point for all of them. 1.5 for creating an accumulator, which is int total equals 0. Make sure that it's initialized. Declare and initialize. We took points off when we just said int total, semicolon. It has to be initialized to 0 because if the orders array list is empty, it's supposed to return 0. And how will it do that unless it's initialized? Invokes a getNum object on an object of type cookie order. So we do that. That's a half a point. Correctly accumulates total half a point and returns the total here. So looks like we've got a 3-point start, which is a pretty easy get for this problem. So let's look at the second part of it, which is removing variety. Okay, this is a little bit of a longer narrative, but I'm going to go and read the pre and post condition. Removes all cookie orders from the master order that have the same variety as cookie var. Okay, notice cookie var is a string, not a cookie order. So we're going to have to dig deep in there and compare the variety in the cookie order to the string. And it returns the total number of boxes that were removed. Cookie var is the variety of cookies to remove from master order, and return the total number of boxes in the cookie orders removed. So we create a new master order called goodies, and then we add chocolate chip, shortbread, macaroon, and chocolate chip. And then here's the state of the orders, not goodies. I can't tell you how many mistakes were made referencing the list as goodies. It's orders. Remember, here it is, orders, not goodies. And then after removing chocolate chip, it returns 4 because there's 3 over here and 1 there, and it remains in the list shortbread and macaroon. Brownie doesn't return anything. Okay, so I can't tell you again how important it is to remember the method header. Okay, so I'm going to go and show you what it looks like. Well, I copy over the method header. I'll rewrite it, even though it's given. I will rewrite it and set it up. So I have an int total equals 0. Well, this is a tricky problem because If I use a for each loop, I will have begun down a trail that will lead to a mistake. Because when I remove one of these options here in a for each loop, the one after it in an array list slides down. That's the way the remove method works for an array list. It will slide down and I'll miss one of the elements of the list. So I cannot remove using a for each loop. Okay. And the other thing is I got to keep track. The idea of the index, removing one and then having one slide down. If I'm counting up, then I've got a problem. Okay, because as soon as I remove one will fall into, like, say, if you remove it at the 3 position, the one after it will move into the 3 position, and then I'll increase the counter in the loop and skip the one that moved down. So you have to worry about that. So while I'm less than orders.size, here is this .orders.getI. I'm required to do this. .get variety, getting the variety .equals in order to compare strings. Cookie var. Remember, cookie var is a string variable. And if that's so, I want to add it to the total, the num boxes, and then I want to remove. I can't remove something and then add it to the total. So it has to be in that order. And I don't progress in I because I know the one after it's going to slide down. So only then do I do I++ if the orders.get variety is not equal to the cookie var. Then I can move on. Otherwise, I'm going to stay at the same index, knowing that when I remove one, the one after it will slide down into the I position. All right, another way to do this, okay, is to start at the end, okay, kind of like theater seating, which a lot of you missed, right? Start at the end and move down. Okay, so as soon as I find one, I can remove it and it's fine. Who cares if the one that I already checked moves down? Okay, because I already checked it. So each one of these calls orders.removeI. Then I return total. Well, let's look at how it's scored. Okay. Well, from experience, I can tell you that most, except for like the truly gifted, maybe 10% miss that idea of when removing from an array list, the subsequent elements shift down. Okay, so let's look at the score. All right. Identifies and remove matching cookie order. Accesses an element, half point, right? Did you write a loop? Compares cookie var with get variety of a cookie order object. Must use .equals or compare to. Can't use equal to compare objects, and string is an object. So you have to use .equals, and that's why you have a .equals method within a class. Okay, so that it overrides the capital O object .equals, which compares memory addresses. So you compare a half a point, and then you compare parameter with all cookie order objects. Okay, in other words, your loop will run with an out of bounds error, no out of bounds error. You remove one element, it's okay. Removes only matching cookie order objects. You can remove any element and get a point. Removes all matching elements, no element skip, which means, hey, what happens is all but the very best will, get 3 out of 4 there. Because if you didn't account for the orders shifting down, you can't get that last point. Computes the number of total boxes, creates an accumulator, declares an initialized, invokes get num boxes on an object of type cookie order half point, correctly accumulates, okay, you lose a half a point there because if you didn't take into account the shift down, the one that shifted down may be one that matches the variety, and so you can't correctly accumulate those total number of boxes. So you're going to lose a point and a half and returns a computed total. So if you try to use goodies instead of orders or uses an incorrect name like master orders, you start losing usage problems like you use variables that are out of scope or not in the class, and so you're going to start losing at points. That's worth 6. All questions are worth 9. So, one of the things that I want to summarize is when approaching this problem, I really skim it first to see what's required. Okay, if I get to the bottom and it says, implement this in part A and that in part B, and I see that master order is a list of cookie orders, then, I can go back up here and look at this and try to understand it. If I think cookie order is the beginning and end and the sliced bread of this whole problem, by reading it from top to bottom, I will have put undue emphasis on the cookie order. It's kind of a helper or a companion to the master order class. And so I want to briefly go over a couple of other things, okay, in the scoring. Okay, in general, there are non-penalized errors. They change from year to year, okay, and there are minor and major errors. I want you to take a look at these when you do the FRQs and score them so that you have an understanding that you can make a few mistakes, okay? For example, missing public on a class or a constructor header. They do change without warning from year to year. So these are the 2010s. All right. People do lose minor errors and such like that. So as I look real briefly to the next problem, I see that this is a whole bunch of narrative. I'm going to skip down to the bottom, okay, maybe, and say, write the AP line class. And so now I know why I'm looking at the stuff up above. I'm going to write a class. And then your implementation must include a constructor that has 3 integer values, A, B, C, and it has to include a method get slope, and a method is online. And your class must produce the indicated results when invoked by the code segment above. You can ignore issues related to integer overflow. And now I can look back and read this problem. Some people say, look for the verbs in reading the problems because they're the action elements of it. That can only get you so far. And now when you see like an AP line constructed here, you understand that this is sort of a guide. There has to be something on the other side, including a constructor that would successfully create an AP line using this. Again, I think a quick skim and then a thorough read might be the approach to get a sense of why you're looking at the problem. So the thing that I also want to say is you have about 20 to 25 minutes per FRQ, so you do need to keep track of time. Good luck. Okay, reach out if you have any questions. Thank you for watching.